Hello again. Hopefully you guys are doing well. We are covering 2.3 in this section. So take notes. Have your phone ready in case you need to ask me some questions. All right, rate of change and slope of a line. Okay, so last time we were looking at how to graph a linear equation. So we were graphing these lines. Okay, so one particular aspect of a line is the slope. Okay, so this section here is dedicated to slope. All right, so first of all, before we get into it, suppose that this person is walking in that direction. Okay. So he's walking. And suppose the road suddenly starts to do this. Okay. So would you say he is going uphill or downhill? Okay. So hopefully you said uphill. Okay. So when he is going uphill in this direction, then we say that this line has a positive slope. Okay. If the road starts to do this, okay, now he is going downhill. So here we say that it has a negative slope. Okay. And then if the road changes again and it just kind of does this, it's completely flat, then he's not going uphill, he's not going downhill. So there is no slope. So this here line has a slope of 0. Okay. And then if suddenly the road does this, well, then now he's in some crazy land and he can't go up this road anymore. And this here slope of this vertical line would be undefined. Okay. So make sure you're aware of the directions of your lines and what sort of slope they have. So they will either have a positive slope, a negative slope, 0 slope, or undefined slope. Okay. All right. What we're doing here in this section is finding slope, but we're going to be finding slope in 3 different scenarios. We're going to be finding slope given, number 1, a graph. So if you have a graph, we're going to take a look at how to find the slope of that graph. Okay. And then we are going to look at how to find the slope given 2 points. So if you're given 2 points, no graph, how do you find the slope? And then we're also going to look at an equation. Okay. And how do we find the slope when you have no 2 points, no graph, but you're given an equation? Okay. So there are going to be 3 different methods here. Okay. So before we get into them, let's also talk about how we find slope in general or what it means. So we use the letter M for slope. Okay, so maybe some of you guys remember slope as rise over run. Okay, or you remember it as the change in X, change in Y over the change in X. Okay, Maybe you remember it as a formula. Okay. So maybe you remember it as y2 minus y1 over x2 minus x1. Okay. All of these are different ways to look at slope. Okay. All right. So let's take a look at a graph. Okay. So again, we're going to be looking at these three situations, and we're going to take a look at how we find the slope given each situation here. So let's start off with this first one, slope given a graph. Okay. All right, so I'm going to go ahead and draw a graph here. So suppose that I have this XY axis. Okay. And I'm going to go ahead and 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. X axis, Y axis. Okay. So suppose that I have a point right over here. I'll make it clear, a simple point, so you can see that. Okay. And suppose that I have another point over here. Okay. And so here's my graph. And I have to find the slope. Okay. So here, I can just go ahead and count so I'm going to be using this one over here, this idea of the slope being the rise over the run. Okay. Rise over run. So over here, I'm going to count the rise between these 2 points. So that's that vertical distance. Okay, so here, let me go a little thicker here. Okay, so here, the rise would be right here, and that is 1, 2, 3. Okay, and the run, here, let's write that down. So here, my rise is 3. Okay, and then the run is this distance here. Okay, and my run is, if you count that, that's 1, 2. Okay, so the run would equal 2. Okay, so here, if I wanted to write my slope, I would use the idea of rise over run. And so that would just be 3 over 2. Okay. Now, if you look at this, and this is a common mistake, to leave it as 3 over 2. Okay, so those of you guys at home, why is this not correct? Kind of has to do with this up here. Okay, yeah. See how the line is going downward like that? Okay. Isn't our line going downward? Okay, so here you really have to pay attention when you're doing this counting rise over run, because you not only have to count your rise and your run, but you also have to take into account which direction your line is going. So here your slope is actually negative 3 over 2. Okay, please note whether you put the negative there or there or there, it doesn't matter. All of these are the same. All of these mean that 3 halves is negative as opposed to positive 3 halves, right? Okay. All right, good. All right, so let's take a look at finding the slope given 2 points. Okay, so here, when we're given 2 points, we are going to use this idea. Oops, didn't mean to do that. Okay, we're going to use this idea right here to find the slope. Okay, so we're going to be using that. We'll write it down over here, so don't worry about it. Okay, so when you're given 2 points, like this one over here, find the slope, that path of the line that passes through these 2 points. So I'll give you the 2 points. So it passes through -3, 5, and -7, -1. Okay. All right, so we are going to use the slope formula. And I will write it down over here. Slope equals y2 minus y1 over x2 minus x1. And that just means because you have one point here and another point here, both of them have an x, both of them have a y. So to keep things organized, we call one of them the first x. We call the other one the second x. And that's what these mean. Second x, first x. Same thing with the y's, since you have 2 of them. To distinguish between the 2, we call one of them the first y, and we call the other one the second y. Which one? It doesn't matter. Okay? But this is the formula you use. Okay? All right, so I am going to go ahead and label my points. Again, it doesn't matter which one you call the first point, but since this one is written first, I will go ahead and call that the first point. So then this will be x1 and y1. And this one here will be our second point, so I'll call that x2 and y2. Okay? All right. So now I just go ahead and plug into this formula. You know what? I always recommend students to use parentheses. So go ahead and tweak your formula so that you have parentheses around these values. Okay, so slope equals y2, which is -1, minus y1, which is 5, over x2, that's -7, minus x1. x1 is -3. Okay, so it kind of helps keep things organized whenever you have all these negatives floating around in here, plus the subtraction in the formula. Okay, so a lot of times students will think that that subtraction counts for this -3. It does not. Okay, so just make sure you use parentheses. All right, so we see here the double negative down below in the denominator. Double negative becomes positive. Okay, so I'm going to go ahead and fix that there. Okay, and so this is like the sign of 5. So that's like -5 and -1. So that's -6. And down below, that's -7 and +3. So I get -6/4. Double negative becomes positive. And then they're both divisible by 2. So I get 3/2. And when we're plotting points, it becomes important to change mixed numbers into into, changing improper fractions into mixed numbers so that we can see where on the number line it falls. But here with slope, we're going to leave it, okay? Because remember, slope is rise over run. So we want to know how much are we rising and how much are we running if we have to do any sort of graphing, okay? Rise 3, run 2, okay? So just leave it like this. You don't have to change it to 1.5. When it's written as 1.5, it's kind of hard to tell what the rise is, what the run is. Okay? All right. And then the third case, the slope given an equation. Okay. So over here, so if you recall from the last section, we said that standard form of a line was this, ax plus by equals c, right? Okay, so there's also another way a line can be, an equation of a line can be written, and that would be called slope-intercept form. So that happens when you have this equation rewritten in a way so that the c is not by itself, the y is actually going to be by itself. So all of these guys move over to the other side. So slope-intercept form looks like this. A y equals, so if it says y equals, you're good. If it says 2y equals, you still have to finish it. Okay, so that it says y equals 1y, positive 1y equals. And here, okay, so this is still, it's basically the same equation up here with these guys moved over. So like this moves over and whatever that number is next to x is now called m. And then we call the constant, the one that doesn't have a variable, we call that b here. Okay, but you'll see when we have actual numbers plugged in that you can rewrite the equation in either way. Okay. All right, so this form right here, slope-intercept form, this is the one we're going to be using to determine what the slope is, because when it's written in slope-intercept form, okay, it's called that for a reason, because right here, this m, this number next to x, is your slope, and this number b is going to be your y-intercept. So 0b will be your y-intercept. Okay. So that's why it's called the slope-intercept form. Okay, so let's take a look at an example. So if we're given an equation, how do we find its slope? Okay, so find the slope of, and we'll look at 3 examples just to make sure you understand this one. So find the slope of each equation. All right, so let's start off with this first one. So A, y equals 2/3 x minus 5. So this is probably the easiest of the 3. Okay, so we can see here, this is written in slope-intercept form. The y is by itself. Okay, and when it's written by itself, the number next to x is the slope. Okay, so that was pretty easy. Nothing to be done. Okay, let's take a look at this one. Y equals 9 minus 2x. So this is kind of written in slope-intercept form. Okay, when y is by itself, the number next to x is your slope. So here, your slope would be, what would it be? What do you think? -2 is correct. Okay, so yes, you do have to take the sign there. Okay, and let's take a look at this third example, letter C. Suppose it's written in standard form, not slope-intercept form. When it's written in standard form like this, then what you have to do is solve for y. Okay, you have to rewrite this equation so that the y is by itself. And so you have to solve for y using all of your solving methods. So if it's addition, you do subtraction, etc., etc. Okay? All right, so let's go ahead and do that. So let's subtract 3x on both sides. Okay, and when I do that, the 3x's will cancel. Okay, and I will be left with -5y equals, and right here, you really can't do anything with this because these are not like terms. This one has an x, this one does not. So I'm going to go ahead and write the -3x first and then the +10. Okay? Since I'm trying to get it in this form and the x term is first. Okay, we are almost there. We just need to get the y by itself. So I'm going to go ahead and this is multiplying by -5. So the opposite is to divide. So I'm going to divide everything, all three of these, by -5. So divide that one, and that one. Okay, and so here we get the y by itself. And we end up with y equals double negative there becomes +3/5. And 10 divided by -5 is -2. Okay, so now I have it in slope-intercept form. So my slope is 3/5. Okay, and so these two were really easy. So this is more like something I would put on a test. Okay, all right. And then the last thing here I want to go over are parallel and perpendicular lines. Okay, parallel and perpendicular lines. Okay, so let's just kind of review this, what parallel means and what perpendicular means. Parallel lines. These are lines that don't intersect. They don't cross. Okay, so when you look at them, they look like this. Okay, they don't cross. They're not going to cross ever. Okay, and so what happens is here, parallel lines actually have the same slope. Okay, so here, if this line here has a slope of 2, then this parallel line here also has a slope of 2. Okay, they have the same slope, but they have different y-intercepts. Because if they have the same one, then they're the same line, right? Okay, so they have to have the different y-intercepts. Okay, so when you have it written like this, the slope has to be the same. but the b value, this number, has to be different between the two equations. Okay. So here, let me give you an example here. So maybe you have 2/3 x plus 5. Well, so that's one line. So the other line has to have the same slope, right? So 2/3 x. Okay, 2/3 x, but it has to have a different y-intercept. So it can't be plus 5. It could be anything else. So maybe it's something like plus 1. Okay, so that's what I mean by parallel lines. So these two equations of lines have the same slope, but different y-intercepts. Okay, and then last thing, perpendicular lines. So these are lines that intersect, but they don't just intersect, they intersect at 90 degrees. Okay. All right, so don't copy this down because I'm just going to kind of draw you an example. Okay. Okay, because even though these here intersect, they don't cross at a 90-degree angle. So they have perpendicular means they cross at a 90-degree angle. So like this. Okay. It has to be exactly 90 degrees, which is symbolized with that little box. Okay. All right. Let me erase this. Okay. So not enough that they intersect. They have to intersect at 90 degrees. Okay. All right. So let's go ahead and draw that. So if this is one line, then it has to be like a cross. Okay. And right there, my 90 degrees. Okay. So if you notice here, when we're talking about perpendicular lines, one of them is a positive line, right? So this one has a positive slope. And if you notice here, this one over here has a negative slope. Okay. All right. So here they don't have, so we already know since one of them is positive and the other one's negative, we already know they're not going to have the same slope like parallel lines. Okay. So what happens here is they have negative reciprocal slopes. Okay, so what does that mean? Okay, so here, I'll give you an example. So if one of them is 2/3 x plus 5, okay, then the other one, this right here, negative reciprocal. So opposite sign, and we're going to flip this. So negative 3/2. Okay. And here, if you have the same y-intercept, that's fine. The only thing here is that the slopes have to be negative reciprocals, opposite signs and flipped. Okay. And doesn't matter about this. Okay. If you have any questions, make sure you message me. Or if you want me to do a video that does a little more explanation or more examples of anything, let me know. All right, until next time, enjoy your day or night.